Welcome, everybody. My name is Sean and I work for CERIAS. I'm the Director of Strategic Partnerships. And I want to welcome Sanket Naik today. He is a boiler maker. He has a master's from computer science from Purdue, and he has done research with CERIAS in the past. He's the founder and CEO at Palisade, building a purpose-built AI platform enabling enterprises to automate their security program and unleash their business potential. He enjoys giving back to startups through investing and advisory roles. Before Palisade, he was the SVP of engineering for Coupa. In this role, he built the cloud and cybersecurity organization over 12 years from the ground up through an initial public offering followed by significant global growth. He has also held engineering roles at HP and Qualys. So his talk today, AI agents for DevSecOps. So again, welcome, Sanket. Thank you for coming back to Purdue.
Thank you for having me, Sean, and I'm excited to be back here. I landed last night, and it's always exciting to come back on campus. There's a lot of nostalgia of coming back on campus. I'm excited to be here. Things have changed a lot, but for the better. As Sean mentioned, this was perfect. So that's my background. I live in the San Francisco Bay Area. Did my master's from Purdue. Worked with CERIAS. Did research with Dr. Atala on natural language processing. Originally from Mumbai, did my electronics engineering there. So as Sean mentioned, after I graduated to Purdue, I went to Qualys. It's a security scanning company. Was very early there when it was a 60% startup. Built a lot of their software, including there's a service out there called SSL Labs, browser check, a lot of early versions of those. Hundreds of security signatures for the Qualys product. Then went on to HP.com as an architect. And then with Coupa, I was there for 12 years, building things ground up. I remember we went straight from the garage to the cloud. Literally when AWS EC2 was in beta and we were moving things to the cloud. And that's kind of the genesis of what I'm doing with Palisade. I like working with new technology. So Qualys in 2001 was a software as a service company. When that was new, when I was at Coupa, I was doing cloud when cloud was new, and now I'm very excited to work with AI and to see how this once in a lifetime transformative technology for a lot of us can be leveraged towards DevOps and cybersecurity. That's kind of the genesis of what we are doing at Palisade. And so this is the problem we are seeing in the industry right now. So with AI generated code and coding assistants like the cursors and Claude Code and others, we are seeing developers writing an unprecedented amount of code. So that this could be just using writing new code, using it to expand on existing codes, all kinds of things, and they are writing a lot of code, a lot more lines of code. But what we also see, which wasn't happening before, previously, if any business wanted to write code, build a product, they had to find engineering time. They had to go to the software development team and ask them, hey, can you guys build this for us? Or they had to find software developers in the market to build a product. And what's happening now is that paradigm is shifted. So you have people who have no software development background, writing code, building apps. And that's both exciting and scary. So the examples of people doing this would be a product manager at a company who previously would write the specifications, and the developers would be writing the code. The product managers themselves are building prototypes. You have UX products like Figma and others, and some people are doing Figma. I mean, the big companies are doing Figma, but the smaller companies, they're choosing to just build prototypes. Because they can just demonstrate to the developers what they would like to build, and it's quick and easy and fast. So we see that evolution in the market. We see it in other, this is not limited to product. We see it in other business functions. This is happening in sales, where you might have sales engineers. These are people who support the sales representatives in the field. And previously, they would have to write some scripts or do some mock-ups or work with engineering to demonstrate new features in the product, or create synthetic data to put in the product to demonstrate the value of the product. And they are building apps because they can demonstrate value to the customers quickly. And then if the customers like the product, they can then go back to engineering and say, customers like these features, can we now properly build this features? So we're just seeing this proliferation across the market. The challenge is that this is where I said it's both exciting and scary. So the exciting piece is it's unlocking new capabilities. There's people who previously could not do a specific task, or could not did not have the capabilities. Now they have superpowers and they can do these things. The scary part is a lot of this is slop code. So just a raise of hands, like who is like coding with AI right now in this room? Almost everyone is coding with AI, right? And that's very common, right? So everyone's coding with AI, and if you're coding with AI, how do you feel the code is that you get out of AI versus what you would have written yourself? Little complex sometimes. Complex. Any other adjectives?
Simulation is the real code.
Simulation instead of real code, right? Right. So that's what you want to say?
It's more well defined.
It's better defined when AI writes it, or
It's like, yeah, because when we write it, it's like we mostly use short forms and
Okay.
stuff like that.
okay. And that's a great point. The nice thing is it's very verbose. Sometimes the bad thing is very verbose. And so developers traditionally have love to have bragging rights, how they compress like a 100-line function into 3 lines of code. And AI will write 100 lines of code. It might write 300 lines of code because all it's trying to do is do the job. It doesn't care about how much code it writes. And that can be a downside because now you're creating a lot more code to maintain, which means there's a bigger attack surface, which means you could have both vulnerabilities, so on and so. So there's both of those things, but what it does is also the code might be better documented because it's AI writing the code, explaining why it wrote the code, which developers might sometimes be averse. So that's a challenge. Now it puts, but at the same time, if you take enterprise companies, they, while all these, there's been explosion in the amount of code, they still need to follow good practices and guidelines and meet regulatory and compliance requirements to ship their products. So traditionally the enterprise in most companies, mid-sized companies to larger companies, there's asymmetry between product security engineers and developers. And so product security engineers are typically those people who will do things, review the product and the code from a security perspective. So they might be doing code reviews, they might be doing design reviews of new features of the architecture, making sure that it's compliant with the policies that the companies has and also compliant with any regulatory requirements they might have. But typically there's been an asymmetry that most mid-sized companies, there's a ratio of about one product security engineer to 200 to 300 developers. And so as you can imagine, there's a cognitive difference too, because you have developers who are working in dev teams who are only working on 1 or 2 or maybe 3 products, versus a product security engineer has to support multiple products. They could be supporting 20 products. They're also not in the flow of the writing the product all the time. So they're getting interrupted. There's an interrupt, they're working on something, the interrupt comes in, hey, do a design review. So then they have to come up to speed on, there's a new technology that the development team is introducing. So they have to learn that technology. They have to refresh their memory on what was this app or product that the design review is being done for. Then they have to figure out what are the new features in the product. And then they have to figure out, okay, let's make sure these things are secure. So it's a multi-step process on it's as a part of that, they have to extract components out of the design document, they have to create data flow diagrams, they have to do threat modeling of the data flow diagram. So this could take anywhere from 20 to 30 hours for a product security engineer over multiple weeks. There's a lapse time because they're going back and forth, studying things, building diagrams, getting feedback, asking questions. And so this is putting a lot of pressure. So now because you have existing developers generating a lot of lines of code, new people generating a lot of lines of code, and all this is piling up on the product security engineers. At the same time, there's pressure on the business to ship this code. Almost every industry out there feels there's an existential threat from AI, in the sense that if they don't adopt AI fast enough, they will lose their competitive edge. So it's just general emotion in the market to move fast with AI. And obviously, as if you read in the news, it's a little bit of fraud. Like companies are getting too ahead of themselves with the hype and then having to course correct afterwards and things like that. So this is just going on in the market. But there's general from the market, from the board, from investors, there's pressure top down to constantly do something with AI, to innovate with AI. And so we have talked to our customers where the CEO will say, hey, the product designer built this product, why can't we ship it? And the engineering team is, no, there's this laundry list of things that it's not doing well, we cannot ship it. So there's this tension pressure in the market. So that's kind of the definition of the problem, the challenge in the market. And these are some examples of the challenges with the AI generated code. I picked some examples which have been the news. So the first one over there is where a person had written an application, and that person had explicitly given instructions to Replit saying that, hey, we are in a code freeze. The databases are locked down. Don't change anything. And it still went ahead and deleted the entire database. And when that same person prompted with the coding assistant later, it admitted to it. I mean, it's nice. It's not trying to hide it. It said, I did it. I'm sorry, and I violated all these rules. But that doesn't help because the change of freeze was overwritten. Another example is this one here where because the models are trained on all the code examples on the internet out there, it sometimes gets confused between programming languages, patterns, things like that. And in this example, it generated, instead of generating a UUID per record, it generated a same UUID for every record and completely messed up the application. So that's another one here. There was an outage and they had to go back and reverse engineer and fix the code. Third example here, which is interesting, while AI helps with good example, if AI has good examples that it's trained on, it does a good job. But on the internet, there's lots of bad examples of coding. And this also exists within the company's code base. So while the company might have taken all kinds of precautions to write good code in the past, but there's also some bad coding patterns in the data in the company's code base. And if the model is trained or fine-tuned on that or post-trained on that, it learns all of those bad habits in addition to the good habits. And so you don't know which one it's going to use. And so there's been a lot of research, and you'll see examples where the co-pilot is writing bad code, which you were not expecting to write. So it's writing worse code than what an average software engineer. So these are some of the examples. Um, so this is something that we are looking for as a company, is that, hey, can we help use AI agents for the specific area of DevSecOps, which is the area for shipping code, uh, and can we apply that to AI generated code? And this is a framework which has been the DevOps framework, which later evolved to the DevSecOps framework. This has been around for about 10 years or so. And what it shows is it's like the software development life cycle from planning the software to coding it, building it, packaging it, getting it ready to deploy, testing it, deploying it, then operating it while it's in production, monitoring it while it's in production, and doing auditing on it to make sure that it's not running out of compliance. So that's the basic software development lifecycle. And what it shows here is the opportunities at various places in this lifecycle where we could leverage AI to help ship AI code, the large amount of AI code being generated. So I already mentioned one which we talked about for a bit, which was the first one on there, the design review, data flow diagrams, and that one. So I'll just leave it out here. It's going to be part of the presentation and the slides. But you can see there's different opportunities to do here, and there's other companies exploring this in various areas. But there's a word of caution, right? We talked about a lot of challenges with AI. And if not done correctly, the AI agents can also inherit those same challenges. The first example is that it could miss some critical issue. So there's a possibility of false negatives that because it's at the end of the day, it's a trained model. And based on your prompt, it's navigating the neural network and coming back to you with some answers. And it's very stochastic. It changes based on prompt, but it also changes based on time. It also changes based on the model. And at this point of time, everything's changing all the time. And so there's a lot of variability in the system. And so there's a possibility that you could miss some critical issues, right? So we have to be aware that it's not going to, it could be better in some places, but not good in some places. The flip side of that is it also triggers false positives, right? So because it's working on patterns, so it can find some things which it's triggering false positives. So it could be making the job worse by finding false positives that you now have to triage and prioritize and figure out which ones are the sift out the right. The second problem could be is hallucinations. I mean, I think everyone's familiar with this. Is a lot of AI especially chatbots, but models in general, are trained with the intent of being agreeable. They're trying to please and with being persuasive, right? They're very persuasive and trying to please, and they kind of trying to understand your prompt and navigate to find the best answer that will make you happy. And a side effect of that is that when you look at it initially, it might look plausible, even right, and but it could be just incorrect. It just looks right on the surface, and if you double click into it, it might be incorrect. And this also depends on the skills of the person reviewing. For example, even within like our company, if you look at, if I looked at something versus I've been in cybersecurity for about 25 years, but I have someone on my team whose day job is doing security reviews, and that person is more fine-tuned on doing security reviews, and he catches things. Like I might take a cursory look and think it's okay, but he's like, no, it's not right, and these are the reasons it's not right. So that's one of the challenges. Like it might lull you into thinking it's correct, but you have to double click. The third thing I talked about a little bit, which is the inconsistency, that the results vary over time, over models, and with inputs too, because at the end of the day, you're giving it an input, which is an instruction. Everything's going on the same control plane. The system prompt, the user prompt, everything's an instruction that's going into the model and it's giving outputs. And so while your system prompt might stay the same, the user prompt, which is the user input, which could be the code or could be a design document, that's varying every time. And that small variance can cause in the input can cause a big variance in the output because it navigated the neural network differently based on certain keywords. Right, so that's also one of the challenges. And then there's over reliance. This is more of a emotional constraint that one of the things that we're seeing with AI in general, not just in cybersecurity, is that in some cases it's creating intellectual laziness, right? So you do something quickly with AI and you get good results and you're happy, and then you kind of punt it over to someone else and thinking that it's good. So that, and there's a new term, if you look at it in the news, they call it work slop. So because you can do things quickly and they look good, then you're creating a lot of substandard material very quickly and inundating other people with it, right? And so that's one of the risks, that you kind of develop excessive trust or intellectual laziness, and it reduces the ability that we have built over time through drills, through practices, to learning, to do to review things carefully, that detail orientedness of doing things, and that can potentially over time create blind spots for us, right? So these are some of the challenges. I'm sure there's more. So how do we address these? So here's some of the techniques that are out there that you can potentially look at in general. We call it AI engineering. So the first one is just prudence with using AI, right? So then, and if you're trying to do something quickly, you can go into an LLM chatbot. You can ask a question, you get quick good answers, and that's great when you're trying to do something which is a low impact, right? But if you're trying to do something that has high stakes, high requirements, high stakes, a higher bar to cross, then you need to break down the problem, right? So you take the overall problem and don't use and use the old deterministic techniques where possible. So for example, if you want to parse out a document, there's a lot of older techniques out there like regular expressions, JSON parsers, things like that that can use to parse out a document, and where they work, continue to use them because they are predictable, right? You know that they are going to be accurate. You don't have to worry about that part. And then you pull out the problems where LLMs are really effective. All right. So if you took the same example that I mentioned about parsing a document, LLMs do really well with that, much better than any other technology previously available in terms of distilling a document, getting both content and intent. And so, but you also have to kind of sandwich it between the deterministic part and focus the LLM where you need to do the non-deterministic part, and then again refocus it using the deterministic part. The next part is prompt engineering. So prompt engineering, we have seen generally works well when done by domain experts. So if you have two cybersecurity people doing prompt engineering to get some outcomes, then the person who has more experience, more domain expertise is probably going to write the right instructions to get the right outcomes with the LLM. So that's an important component. With working with AI is the ability to do extraordinary prompt engineering. You get great results when you do extraordinary prompt engineering. So that's also a skill to learn. The third part is context engineering. So general purpose prompts are good, but if you want to solve specific use cases, for example, if you're doing code reviews, and if you use a linter, use a static code analysis tool or a linter to analyze that code, it will find the static code issues in the vulnerabilities in the code. And it will usually suggest some code fixes. All the modern linters suggest some code fixes, but usually those are generic. And most of the times, if you take a experienced developer, they are going to either not use that or get annoyed by it that you suggested an inappropriate fix that they wasted their time on. So the way to address that is you give it a context of the code so that it can suggest a better code fix. And many companies implement things like retrievable augmented generation RAG pipeline so that if you have a large corpus of code, you're not providing the whole code base to every prompt that is being sent at. There's constraints with doing that. Most of the models have context windows, so you can send in the whole code base. But that also causes problems if you send in the whole code base or even too much code. It actually confuses the model because again, it's trying to make decisions based on all the words that are coming in. And so you have to find a fit of what is the right amount of code. So which functions, which files, which words, which test cases, what are all the things you need to send into that prompt along with the prompt itself so that you get the right output. And so then there's a new term for it in the field right now called context engineering, which is the combination of the prompt and the content that you have extracted to send to the LLM so that it generates the right output. Right. Again, this is again a combination of a science and skill. So there's certain things that work with certain models better than others, but it's also developing the skill of doing it. And the third case is testing. So this is a combination of traditional software engineering doing testing. So and this is one area where test-driven development really helps. So if you see a lot of the companies which are doing well with implementing AI, where the products are actually working well, they do a lot of test-driven development. So what that means is if you are using AI to say write a use case of code review or design review, once you come up with a plan of how to do it, you also write the test cases. You write the inputs that you're going to test with. You write the test cases that you're going to test the output with. So you're writing all that upfront before even you do the development, the prompt engineering, things like that. So when it happens, you know what's a good output or a bad output. And the better you get at doing that, the testing, the better outcomes, outsized outcomes you get with it. So that's the just traditional testing test cases. This could be things like, for example, if you get the output from AI, generally now most models have become good with giving outputs in JSON. That wasn't the case last year. They got really good with it. But we still see it hallucinate in different ways. For example, if we give it a JSON schema, we will see sometimes that it will skip a certain section in the JSON schema. You don't know why sometimes. It just happens because it's stochastic. And so you want to be able to catch that thing. So that's a very structured thing. You just want to write a test case that you got the output in the right schema, and if you didn't get it, then you need to retry. Like that's if you send that to the next step in the pipeline, then it's just going to have a cascading effect, and a lot of times you won't know what happened unless you have like logging at every step and you're able to reverse engineer. You won't know what happened. So the better way to do it is to preempt it by writing the test cases. And then the next part is to use AI for testing. So there's a whole class of test cases called LLM evaluations. There's various companies and open source groups working on writing evaluations, and these are very also domain specific. So they vary by industry and use case and things like that. So that's a part. And again, it's kind of like the domain experts are good at writing evals, but again, with caution, you're using AI again. So you have to be careful in how much trust you place in the evals, but it raises the bar to make sure you catch things that you could have missed if you hadn't used the evals to check the code. Right. For example, there's things like ground truths that suppose you're generating like a So for example, if you have your entire software code base is written in JavaScript, but then the output from a code review somehow inserted Perl in it, then you would your the deterministic test cases would be hard to write a test case to catch that, but you can write an eval to catch that it mixed in like the wrong programming language in the output. That's an example of that. Next part is guardrails. So I have there's been some great work done by OWASP. Is everyone familiar with OWASP? Right, so absolutely you should keep track with that. A lot of great work done, and again, OWASP LLM top 10 is almost 2 years old now. There's a lot of fresh work being done there, so keep up with it. But making sure that the things that they mention are addressed. So using the right libraries, right techniques to make sure that these are incorporated within the software development lifecycle. And then the second piece, which is coming back to the specific implementation, right? So you could use OWASP top 10 LLM model, and everything might look good, but it might still violate your company policy. So you also need to make sure you have the right guardrails in place to make sure that whatever you use cases you're implementing with AI, those meet your company policies. And the biggest caution is of course human in the loop review, and the importance of this goes up as you get into more and more high risk areas or mission critical areas. So for things that are not are mundane or not that important, for example, during travel planning, maybe it's okay. So for example, I don't know how many people have had this experience. If you're traveling somewhere and you ask for a list of restaurants, I've seen like a bunch of them don't exist. The restaurants actually don't exist, and the LLM hallucinates on it. But you're okay with that. You're going to go in maps or something, look up before you go, and you will confirm it, and it's low stake. But if you're using it in the company, at work, and it's critical, then you want to make sure you have someone who's reviewing the work. But also use that as a feedback loop. So there's someone who's coming in, and if you look at even the foundation models, they employ thousands of people across the world to do the labeling. So there's reinforcement learning with human feedback that there's actually people looking at the outputs from the training runs to make sure that the outputs are right, and if they're not right, that feedback is getting incorporated either into post training, fine tuning, something like that. So this step is important and essential for high risk use cases. Okay. So just in summary, the key call out is just because we can use AI now for coding, building apps quickly, doesn't mean we throw away a couple of decades of cybersecurity hygiene that we have learned, and especially CERIAS has been one of the pioneers in doing that, in doing a lot of the cybersecurity research and frameworks. So we still need to practice all the hygiene. But while we do that, my advice to everyone, especially to students, is that they embrace an AI first approach to solving problems. So we need to start thinking of how to work with AI to solve problems. So always think of that. Hey, let me go see what I get out of the LLM, and maybe I get some good ideas I wouldn't have thought about. Maybe it gives me hints to look at places I wouldn't have thought before that hasn't happened in my learning in the past, right? So it's a good way to learn and explore and quickly, with the caution of not getting intellectually lazy and assuming that everything's correct. So we still need to have some skepticism. I think cybersecurity people are extraordinarily good at having that skepticism. So we need to continue to do that, but also embrace and explore AI. The second thing is I went through a few techniques. I think that's just scratching the surface with a lot of great AI engineering techniques out there. We need to learn those techniques. to improve the effectiveness of what we are building with AI, to make sure we are efficient, we can do things quickly, faster. To be secure while doing it and stay compliant. So learning techniques to work with AI. And taking the precautions. So, like for example, if you're vibe coding, has everyone heard of like rule set files for? Has anyone heard of like rule set files when you're coding? Some folks have heard of that. So for example, and I'll take one example, and it's not like I've endorse one coding assistant versus the other, but if you're doing Claude code, for example, there's a claude.md file, there's a markdown file in which you can write the rules to make sure that the code that's generated is following certain rules. So for example, if you're writing code in Python, then you can actually write a prompt to ask the LLM to generate a set of rules that write secure Python code. And you can have that as a starting point and use that as your rules file to make sure that, so this is going to be sent along with the prompt. So all the code that you generated, at least some basic hygiene is in there. So these are some of the practices that that you need to follow, but make sure your friends are following too, so that in general, that as a society, the code that we're generating is we're creating less debt for other people. Then the other part is like adding guardrails, like the example that I gave about database code. And it's not even funny because it's almost happened to us where one of our engineers was using it. The good thing is he had guardrails in place where at the end it asked, hey, can I delete the database? And of course the answer was no, but we caught it, right? So it's having the right role-based access control to make sure that when you're giving access, you're only giving access appropriate. Don't give like the API key that gives it access to do everything on your system. Make sure you're setting up the permissions right, that if you need it to only read, then just give it read permissions, narrow down the access to what it only needs access to. And again, also it also prevents data leakage. So for example, we have seen in businesses where you might previously you had all the guardrails in place so that people couldn't download, say, customer data or sales data. And that was great. And now suddenly with AI assistance, because people can do extraordinary stuff, they're starting to connect them to different things. These assistants are pulling in the code, but filling in the data, and now there's possibilities for data leakage because there's a different data silo and copy of the customer data. Then just keep doing some of the hygiene around doing code reviews, design reviews. Make sure you're not just trusting the code that's generated, but you're reviewing it and improving upon the methodology, the prompt engineering to do it over time. And the last part, again, as I mentioned, it's very important is that this field is, I don't think in my 25 years of work experience, I have seen the technology evolving so fast. Like almost anything I assumed yesterday is not true today. And it's just models are changing quickly, the techniques are changing quickly. And so be pretty open-minded that things are going to change, and keep learning, distilling what are the good things out there. So get more fluent, but also be fluent. I frequently ask people when they come and tell me something, I frequently ask them, hey, can you give me a citation? And I want to go back and read it because the information gets outdated pretty quickly. And so someone might be telling me something that they read 3 months ago, and it's outdated now. So it's strange times, or but exciting times. So we kind of, that's where it is. But it's important to stay in this mode that we're both learning and learning quickly, but also adapting. I think that's all I had. I think we have 10 minutes for questions.
Yeah, we do. Yeah, thank you very much, Sanket. So we have questions, and everybody has questions here, and people that are listening in, if you want to put questions in the Q&A, we will field those questions to Sanket.
in this way.
So given
And if
how,
you don't mind, whether it's online or here, if you can quickly introduce yourself, name and whatever your major is.
so I'm Zach, I'm a computer science student, I'm a junior,
Okay.
so I'm an undergrad.
Isaac.
So given how fast models are changing and given that a lot of AI ecosystems, people rely on black box models like Claude, ChatGPT, so on. How do these defense mechanisms continue to be effective as models change, algorithms change, and the implementation themselves change, but the defenses presumably stay static?
They shouldn't stay static. I think my short answer is they shouldn't stay static, and I hopefully I try to emphasize that throughout the thing, and that's why I also put the summary in bold. They cannot, and we expected this. The unfortunate thing that's happening is that the bad guys are adopting AI faster than the good guys. The attackers are using AI at an unprecedented scale. I mean, if you look at phishing attacks, like it's getting harder and harder to tell the good ones from the bad ones, right? And so I think we have to keep evolving, and I see the things that are the technology evolution is in a good way, right? So things are changing, but I feel like in general things are converging. I feel like the models are getting better. The models are getting better, the techniques are getting better, the costs are dropping, right? And I think there's a good tension. You mentioned the closed source models, but there's also newer open source models coming out. The models are getting cheaper, lighter. We're getting to a point where we can possibly do more small language models in addition to the large language models. So I think the important thing is to say it's dynamic, but the thing is, what you need to build, and I hope people start doing it out there. This might be a good project for a lot of you. Is like people start cataloging what is good for certain use cases. Like, hey, this model works best for this use case, and this is exactly what companies are building with AI doing internally too. Like they are trying to figure out which model works for which task, and they maintain a catalog of that, but that constantly changes. So you have to keep updating it. It's nothing can stay static at this point. Any questions? Do you have just if you want to pause, is there anything on there?
Not yet.
Okay, perfect.
Okay, so my question is that.
And if you don't mind introducing.
Yeah,
yourself.
sure, I forgot that.
Yeah.
So my name is Alex, I'm a PhD student here doing cybersecurity.
Perfect.
So my question is that you said that we can use RAG to get like external information to enrich the model. But was there a stage in your company that you needed to fine tune the model depending on the problem you had? Or was it like enough doing the RAG?
I think it depends on the use cases, quite frankly, and it's also as you talk to more and people, you'll get a lot of you'll get different opinions and different approaches, and it literally comes down to the use case, like what are you using it for? And we have explored all options, the training option, the fine tuning option, the RAG option, and it depends on the use case. And actually, sometimes you have to use all of them for different use cases. What we are seeing in general that RAG is working well for a lot of people now, that people are not going back and doing a lot of and a lot of people are not training unless you're a really big company and you both have the resources and the requirement to do it. The requirement could be just privacy requirements that, hey, we need this stuff and we can't put it in the foundational model. But we are seeing that RAG is effective for a lot of stuff, and it's a cheaper, faster way to do things, and definitely we are seeing good outcomes from that.
Thank you.
So, any other question? Right.
Hi, I'm Keshav Vyas. I'm a senior in computer science. So I was sort of thinking like, so a lot of the problems that you described at the beginning about AI were sort of like the AI is not listening in a way, right? So it's almost like, we want these tools to be powerful and therefore we have to give them more privilege, right? So, but we're effectively giving a toddler like access to, root, right? Like that's the scary part about it. And that's why, these guide plans come on. So my question to you is sort of this hypothetical, like, let's say, it listens to you 100%, the person who said that, oh, don't delete the database, it listens. If these tools listen to us 100%, I feel like the examples give that those a lot of these vulnerabilities. So is there anything inherently flawed about using AI for workflows, in giving this privilege, other than the fact that, like, if we can solve the fact that they don't listen to us, I think that solves most of our problems. Is there anything else that you think is a big concern?
I think I think that's a big if. I think that's the fundamental problem right now is the if and again, I think people, I mean, this has been going on for decades, right? People have talked about like artificial intelligence, super intelligence, AGI, all of these things. So I'm not going to get into the AGI and things like that, but you can see like at the point at which it does listen to you and it gives all the privilege, and if it does evolve to AGI, then you have other problems down the line, right? But if we said, okay, that's not gonna happen for a long time, and if it did listen to you, I think it makes a lot of the requirements to have the techniques go away. Right, so a lot of people are spending a lot of time to improve the reliability, the accuracy, having it listen. It's just a hard problem because, I mean, if you take like the genesis of a lot of this stuff is based on language and the transformer architecture, right? So I've talked to some of the experts in the field, and I'm sure there's a lot of experts here at Purdue. But what the experts, and I'm not a ML scientist expert, and what they have told me is that this is stochastic, like the nature of the work itself is stochastic. We could have something revolutionary in a few years, or we might not have it for a few decades. So we don't know, but everyone's trying.
Is one you be one of the time.
Yep.
Yeah, so we just have not a question, but a comment from Sonia, said thank you for your talk. Very informative, full of common sense reminders for all of us in the security arena. And Sonia says that she appreciates you giving your talk.
All right, thank you so much. I appreciate this. I did this last year. It wasn't as fun because I was doing it on Zoom.
Yes.
I'm really excited I got the opportunity to do that. I'm thankful to the person who couldn't make it for the talk, but I got the opportunity because I enjoy this. I enjoy giving back. I enjoy talking to people in person. It was great sharing some of the knowledge that we have learned in the field. Hopefully it's helpful to you, and happy to be a part of it.
Yeah, well, thanks a lot. Really appreciate it.